Got an Akai GX270D, D as in dog. This is the short version of the video that's released to the public, and there will be a long version for Patreon viewers coming up at a future date because this one was a dog. Literally, I spent 2 days on this monstrosity tracing down a defect that's existed in it since it left the factory. Let's check it out. I just may have met my match on this Akai GX270D. It's a 3-motor direct drive auto reverse system, and it's got a kind of a weird problem. You see, when it's sitting idling, the Capstan motor just takes off. When you hit play, everybody knows you dirty old man. When you hit stop, it'll speed back up again. Now, if there's a load placed on it, if I just put my finger on here, I've now put a bit of a load on. It's going the right speed. See? I say rider. But if I let go of it, it'll climb back up in speed again. How about if I go into reverse? Sounds like it's running fast in reverse. And when we go into rewind, sometimes it'll go into fast forward instead. This time it's going to behave. But the first couple times I tried it, it went into fast forward. This could be an interesting one. This. I see. Yeah, this is going to be an interesting one. After removing the screws from the back and from the two from the base, the whole chassis of this unit will just slide out. Now sometimes you got to be careful of putting these things down. Some of them have, this one's okay to sit upright. Some of them you actually have to prop them up because they have boards extending downward. But if you set them up like this, they can get damaged. So let's get the back out of the way so that I can check out the chassis and see why it's running fast like that. So a motor like this is a 3-motor design. It's direct drive. The Capstan is directly driven. Similar to mine, but mine uses a belt drive from the AC synchronous motor. So here's a print of the servo control. This is it is an AC motor, but it's also servo controlled. It has a little pickup here. Provides a frequency generator, which is used by the speed control to provide a correction voltage, which is then used to vary the current into the motor. And somewhere along the lines we are not regulating the speed. So I can say it's got something on this, because this should cut the speed back when it's under no load. I'm wondering if I put it under a load, whether it'll slow down even more. No. So when it's running under load, it seems to be okay. I don't know if that's the right speed or not. I'm not familiar with that music. I guess I should probably play something that I know or put a tone on. But looks like we've got a servo problem. So something on this board here is causing the problem. It's a little more advanced than my GX260 because mine just uses the synchronous motor and has no speed control. With a test tone, 4 kilohertz, 4 kilohertz tone is coming in at 3.94, a little bit low. And Akai was one of these manufacturers that you would swear that the engineers were either all on drugs or they just didn't talk to each other, because typically you wouldn't use the same part designations in the same unit. In this thing, the 24 volt adjustment is VR1. Unfortunately, VR1 is also the 7.5 speed adjustment, and VR2 is the 3 3/4 speed adjustment. So there's two VR1s in here on different boards. And this is something that Akai was bad at. Every single board would start out like R1, R2, R3, R4. Every board would start out with the same numbers. Other companies figured this out. So one board would have like VR101, VR102, VR103. The next board would have VR202, VR203, etc. You know, they would put it, the first number would indicate what board it was from. But no, not Akai. No, they just want to make things difficult. And then nothing's labeled. So I'm looking for, I gotta check my 24 volt supply first of all. I'm looking for terminal 39 on the power supply board. I believe this is the power supply board here. But of course the terminals are not, they're not marked. So what I have to do, I have to count them. And where do I start? Where's number 1? Yes, this is the power supply board. Board's got a number on it, MY222, which is the power supply board. Surprise, surprise. Right here it says MY222. So that's the power supply board, but I gotta find terminal 39, and they're not marked. So I guess it's a trip back to the service manual again to see which one terminal 39 is. Well, the test point I'm looking at is way back in here. It's at the very back, it's pin 44, and I'm looking for 39, so 44, 43, 42, 41, 40, 39 should be this one right here. You have a red and white wire going off of it, if you can see it. Let's remove the power board. Good thing the power's off on this thing. Make sure. Yeah, that's the driver, and it should be this one here. This should be the transistor. It's got a different number on it, but it should be the transistor. I want to see if it's got voltage on anything on it. So, let's turn it on and we'll watch for smoke. 24 volts. 38 volts. Well, my 24 volt supply is there. So to adjust the speed, here's the speed for 7.5 IPS. We'll adjust that to 4 kilohertz on the scope. We'll switch it down to 3 3/4 and we'll adjust this. This is telling me that the adjust that to 2. Almost there. 1.99. So it's working fine under load. Just when the motor's not under load, it winds up. That is a weird one. This is the AC run cap for the motor. And that certainly, usually if they go open, your motor just won't run or it'll run slow. I'm just wondering if maybe it's shorted. But as soon as it's under load, as I say, if I put it under load just by putting my finger on there to slow it down a bit, now it's locked at the right speed, right? It's only if it's allowed to have no load. Right, if I put my finger on the motor here to slow it down at the motor. It's got lots of torque. So the cap should be good. So I'm back to the servo board. I'm going to pull the servo board out because I don't think it's getting the right feedback signal. To take these sets apart, there's a lot of screws you got to take out. You got to pull the whole side panel off to get at that servo board. This whole thing fall apart. It's ridiculous. To get at some of these boards, you got to disassemble the entire machine because of the way they put it together. The servo board won't come out with the side on, so I got to take the side off of it to take that out, and that's held in place by even a screw on the front here. I think there's a couple screws on the front that have got to come out. What is that one? That's not a regular screw. That's a hex key, is it, or is it Torx? It's a hex key. Great. There. One. Now this side piece should lift off. This is the what you got to go through to work on some of these machines. It's just ridiculous. You got to take the side panel off in order to get at the circuit board, because the circuit board won't come out because there's wiring harnesses and stuff that are wrapped around it that are in the way. So to do any work, you got to really disassemble. Even at this point, there's still wires trapping it in place. You got to get these out of the way. Just who builds crap like this? Oh, that's right, Akai. They built crap like this. And of course now there's no support on the unit, so you gotta be careful because it'll tip over. It's holding it up now. There we go. Yeah. Yeah, great design, guys. Great design. That's just so that I can see the servo board and make some measurements and do some tests and look for anything that could be bad on here. This is the sense wire from the pickup on the motor, so I should be able to power this thing up and make some measurements on here. These are the speed adjustments for 7.5 and 3 3/4. Okay, on the oscilloscope we can track the frequency from the frequency generator. This is coming right off the frequency generator on the head. On the motor. This is the frequency generator head. If I slow the motor down, you'll see the frequency drops, and then it starts to pick up again if I let go of the motor. So now we just have to troubleshoot this and trace that signal through the servo circuit and see what's happening with it, because that should be providing a correction voltage at all times to the servo circuit. It doesn't appear to be. That looks right. That's the regulator that drives. That drives this one here. We're looking at the signal coming off of the, this is the transistor coming off the FG where it filters it and amplifies it. So that's off of TR2, I believe. And then from there it goes into, well, it actually ends up going over to the speed controls over here. Where are they? I don't see anything on the speed controls. Interesting. We should have something here. We see nothing. At D1, you should see the signal at D1, and then it gets rectified to DC at that point. Charges up capacitor C3, which is a 0.002 small capacitor. Should be a diode in here. There's the diode there, so we should see a signal on one side of the diode and DC voltage on the other. There's a capacitor here that charges up. It should be this cap right there, I think. Just measure the voltage. Put this thing in DC mode and just slow the motor down and see if it changes. That was there, wasn't it? Yeah, this is the capacitor there. So if I slow this motor down, yeah, okay. So we do see the voltage shift. So that's working to that stage. Where we are here is we are right to that stage of the circuit. That's the feedback circuit. There's a couple stages of amplification after that. Okay, well, I'm back to square one. The servo's working. So I'm monitoring the servo, and how the servo on this thing works is the collector of this transistor, when it wants to speed the motor up, it drops the voltage down, and when it wants to slow the motor down, it goes open. So basically between the collector and the emitter right here, the emitter is grounded, and the collector goes up to this bridge rectifier, which one side is grounded, the other two go back to the motor, one through the capacitor here, and then one back to the transformer. Watch what happens if I slow the motor down by hand. When I was testing this thing, meter probe fell out. When I was testing this thing, I was seeing 46 volts on the collector of the transistor, thinking that looked a little high, because when it's playing, it's down around 23 volts. But watch what happens when I manually slow the motor down. As soon as I get down to below the target speed, the voltage starts to drop, which is to increase the current to the motor and bring the motor speed back up. And once the motor speed's going approximately the correct speed, we got about 20 volts or so. If I let go of the motor completely and allow it to gain speed, the voltage shoots right up. The transistor goes open, which should remove the extra current through the motor to allow the motor to slow down, I should say. It goes open here at the collector, which reduces the draw to the motor, which should reduce the current through the motor and slow the motor down, but yet the motor just keeps on winding up. I've drawn out the control path for the motor. It's an AC motor, but what they do is they control the speed of the motor through the servo circuit by applying a DC control voltage. And how that works is by applying DC to an AC motor. When you've got a DC voltage going across the coil, you reduce the efficiency of the motor, which will cause it to lose torque and slow down. So basically what it does is the control voltage is on this line here. which comes in off this bridge rectifier, and it's controlled by TR2, which was the speed control transistor. We can watch the collector. The emitter of it, of course, is grounded through a couple of 1 ohm resistors, but we can watch the collector, and when it wants to call for more speed, it drops the voltage. When it wants to slow the motor down, it allows the voltage to go up. It increases the voltage. So what we're seeing happening is the servo circuit goes up to like 40 volts on the collector of this transistor, which should be slowing the motor down, but the motor's not slowing down. The motor's continuing to run wild. And you want to speed the motor up, like if I manually slow it down by putting my hand on the motor, we'll see this voltage drop down much lower. If I measure it here, you'll see the voltage. If I can do that, we can measure the voltage. Yeah, 46 volts. Now, if I slow the motor down, the more I slow it down, the lower the voltage drops, because it's wanting to increase the speed of the motor. Let the motor go, and the motor goes faster and faster, and it goes to 46 volts. If I play the tape, you'll see that it locks in around 20 odd volts, 22 volts. If I stop it, oops, that was the wrong button. As the motor speeds up again, there goes up that voltage. Now we're operating under servo. If I slow the motor down, see? As soon as I stop it, that voltage goes up. So the servo circuit is calling for the motor to slow down, and the motor is not slowing down. That proves that the feedback circuit is working. What's not working is control of the motor. I thought about it and thought, well, you know, if capacitor was bad, you normally would have a slow running motor, so I don't think the capacitor's at fault. It may be one of these diodes. And I'm thinking maybe D4, because D4 goes to ground, and that might be lowering the voltage here on pin number 12, coming off the servo board over here. That may be lowering that voltage down just enough that the motor is starting to pick up speed because the voltage is a little bit low. That's kind of what I'm thinking, is maybe one of these diodes over here is gone bad. That's of course back on that servo board again. I'll have to take a look at that and measure those diodes, maybe just change it as a good measure. So I'm just going to change the 4 diodes here, as I've got plenty. They're just standard silicon diodes, just in case one of these ones is breaking down under load. They test okay. When I test them, they test okay, but the way that this thing's behaving, it sure looks like a diode could cause that type of a problem. Okay, got all 4 diodes in. I'll let you in on a little secret. It didn't fix it. In fact, I'm going to start to find something that's most annoying. I'll go over it when I get to there, but the schematic I've got is not the right schematic. I start checking the circuit, and it's not the right schematic. The manual is incorrect. It's a different board than on the schematic. Took me a while to figure that one out. That was an aha moment. I changed the 4 diodes here just on good measure, just in case we had one that was leaky and it was causing the control voltage to be a bit low and therefore not able to slow the motor down. They're all good. The transistor's testing good. Everything is doing what it's supposed to do, yet under no load, the motor speeds up. And even when the control circuit is telling the motor to slow down by applying a DC voltage to the coil to act as a brake to slow it down, the motor's not slowing down. So I'm just checking a couple of the transistors on the servo board here. Even though it seems to be working, it's not working properly, and I keep coming back to this output loop here. We had a leaky transistor, for example. Even though we see the voltage go up to 48 volts or so, it may need to even go higher to, in other words, this transistor is being biased on. So this transistor here could be leaky, this 2SD361. That one is a driver, and that's mounted on this board here, right down here. It's on a heatsink on the board. But that one there, if that were to go leaky, and we still have some control, but if it were to go emitter to collector leaky, it would drive this transistor slightly into conduction. It would not allow this transistor to go completely off. If this transistor goes open completely, the motor should slow down. So I'm thinking maybe one of these transistors has gone leaky. So I'm just going to unsolder the transistor here so I can check it and verify if it's bad or not. I'll tell you right now it's good. I'm in the vicinity, but you're in for an eye-opener when I find out what the problem is. I'm not letting the cat out of the bag yet, because I guarantee there's other ones out there that have got exactly the same problem. And I did search the internet, and nobody seems to have a solution for this one. So this could be the first. That should be disconnected, I think, from the board. Measure that and see whether I get any odd readings. Okay, that way. That junction's all good. That junction's good. I'm not getting any shorts. I'm not getting any shorts. What about resistance-wise? Emitter to collector. That's okay. 3 megs emitter to base. 3 megs collector to base. Emitter to collector is... That's good, nothing there. Reverse the polarity. Well, that transistor is not measuring a short in any way. Let's check the next one back. I'm pulling my hair out on this goddamn thing, and this schematic is totally wrong. I'm just checking to see where things are connected. The base of TR2 should be connected directly to the emitter of TR7, which is the 2SD361, which is this one here. So the emitter is this one. So I said the emitter? Yeah, the emitter. There should be a capacitor between that and ground. A 10 microfarad capacitor, but it's actually 100. But it's not, because if I measure from the base up here to this terminal, I don't have any continuity. But I do have continuity down to this next transistor, which according to this schematic is the 2SC 945. And it's not supposed to be, according to the drawing, it's not connected there. So I don't know where the hell the schematic came from, but it's showing the right number, MY2036. I think that's what this says. MY2036. It's showing the board, but the schematic is not correct for this board. It's no wonder I'm getting the wrong measurements. I'm trusting that the schematic is the real thing, but it's not the way it's wired. It's not wired that way. Somebody that's been modified or something, or the schematic was drawn in error and they've never corrected it. But this is not this. To show you how far off this stupid schematic is, it's showing TR6. If you look at the diagram, it's showing it as a PNP transistor. Well, a 2C945 is not a PNP, it's an NPN. So this schematic that I've got here is totally useless. It's the right number board. It's for the right model number, GX270D. But this schematic is not the right one. I'm curious whether it's this transistor here, even though it tests good. I'm curious whether it's breaking down under load. So what I've done is I've disconnected the base to this transistor. So with no base drive, this transistor itself should not be conducting at all. Therefore, this is coming off this bridge rectifier that's rectifying the AC voltage. I would expect to see this go up to about 100 volts. I see 46 volts and the motor starts to spin. Now, if I disconnect the collector, I should have done this before, but I was assuming that the schematic I was looking at was correct. Okay, I've now disconnected the collector. So this entire board is completely disconnected. I guess I could reconnect the base here, just so that the wire doesn't short out against anything. Okay, the collector is disconnected. We'll clip a jumper on the collector and we'll measure the power. 103 volts. Motor is not turning. The motor is shut off completely. Now I measured that transistor and that transistor tests good. I think that transistor is leaking when it's put under voltage. When it's put under 100 volts, that thing starts to break down. See if I can find a replacement for that. Oh man, that'll piss me off if that's all it was. I've been going around in circles tracing this stupid schematic. I could figure the whole board was good because of the way it was responding. I could adjust it. I could adjust it. It was reading the FG signal, and I was able to control it. So that said everything was working, but it was under no load. The thing was creeping up in speed, and it's starting to look like it's that transistor. Although what threw me here for a while was this is all wrong. This is not the schematic for this unit. Let me see if I can find a replacement transistor for that and try it and see whether that's going to make any difference. Here's another discrepancy. The transistor in the circuit is a TIP47. The transistor listed in here is a TIP48. This, by the way, came from Hi-Fi Engine, the schematic. So if you download the schematic from Hi-Fi Engine for a GX270D, it's wrong. I don't have a TIP47, which is a really high voltage transistor, but I do have a TIP31, which is rated at 130 volts, which should be good enough because it's only running on a 90 volt transformer. So it should be within its operating range. So we'll change this one out and see what happens with it. I'm feeling more confident now after disconnecting this thing and seeing it start to behave like it is expected. The motor not running. And with no drive on this thing and it was still leaking, I'm feeling a little more confident now. Would have probably got to this a while ago if I'd had a proper schematic that was accurate, but that's what happens. So we'll just take this one out. So solder it from the bottom here. tell me there's a nut on the back of this. I guess I gotta take the heatsink out. I think there's a nut on the back of that thing. Of course there is. Dumb design. With paint on it too. So we know this has never been changed. There's not even any heatsink compound on there, or if there is, there's very little. We'll just put a bit on. You know, I didn't even see any insulating hardware that came out of this thing.
Did you hear what I said? No insulator. The light bulb is starting to get bright. Could this be the problem? Could the boneheads have forgotten an insulator at the factory?
Well, now the big question. Why go to the trouble of putting an insulator on there if there's no hardware to isolate the collector from this heatsink? Because this is going to be grounded, and that collector is running at voltage. Because this is obviously going to conduct, unless they're, I mean, it's anodized, so maybe they're relying on the insulating capability of that, but that's nothing. I think that this transistor needs to be isolated. In fact, this transistor probably is okay. I'm starting to think now that the fault on this was leakage from the collector into this grounded, because this is connected to the chassis, into this grounded heatsink. There was no hardware. There was nothing on the back. When I took out the nut on the back here, there was nothing on the back. You guys can look at the video. Nothing dropped off. There was no insulator on there. This was connected directly. You can probably see the black. Look at that. I think that was the problem with this. I think the problem with this thing wasn't so much the... we could put that theory to test. I could just power this. I'll put the transistor back in. I'm curious. I won't screw it down. I'll connect this transistor, and we'll see if the motor takes off with this disconnected from the chassis. Because now I'm really curious. Was that the fault all along? Was leakage through the case of the transistor in through this, through the screw? I'm real curious as to whether that was the whole problem on this unit. So I'm not going to mount the transistor because I'm not going to keep it in here. I'm just going to set it in here, connect it up, and we'll power this thing up and see if the motor still goes crazy. If it does, then we'll change the transistor. But I'm real curious as to is this why this thing wasn't working? I'll put the screw in here just to line it up, just so I can solder it back in. Because the transistor tests good. It does not test shorted. It does not test leaking. And if the motor operates as it's supposed to, now with no connection to the, we'll pull that screw out, lift this transistor up a bit. Well, now the heatsink wants to come with it. I'll reconnect this lead, and we'll see whether this thing spins up fast. I can hear it when it cranks up, right? I know it's going too fast because I can hear the thing whining away. So if this doesn't take off at 200 miles an hour, and also the voltage, we can measure the voltage on the, with respect to ground, we can measure the voltage here. Because I say, when I disconnected the base, the transistor was in cutoff, and I was still getting a voltage drop. But that would be expected if it was grounded out through the chassis here. This would be a good fix if this is what it is. Good one to report on. Okay, watching the voltage. Let's make sure nothing's going to touch here anywhere, and we're going to power this thing up. Seems like the voltage is still low. Oh no, the voltage is rising. It's under control. Damn, this thing's under control. I'm going to try mounting that transistor with some hardware. I just so happen that I have some transistor mounting hardware here from a new Motorola transistor that's come with extra hardware. I got some, yeah, a guy gave me a bunch of old parts that he didn't want a couple of years ago. He gave me, just said, here, there's a guy that used to be, I guess he was an engineer. He was designing crap, and he shows up one day and he says, yeah, would you like some parts? I said, what kind of parts? He said, well, electronic parts. Okay, what do you got? Well, I got a bunch of stuff. You can have it if you want it. Okay? So he gives me all this, I'm going to put the screw through here, and I'll put the nut on the back with the heat sink, with the spacer on the nut to hold it away. Anyway, he gives me all these boxes of old parts that I'm picking through for various projects. Okay, that'll keep that transistor from overheating. So I'm going to measure to make sure there's no short between the screw and the chassis. Good, there's no short. Good, that's good, no short there. Okay, let's power this thing up. I'm just going to watch that voltage, and we'll see how this thing controls the motor speed. Remember, this is the original transistor, just the heat sink repaired. Make sure there's no chance of short here. Okay, fire it up. And the motor spins up, and I see the voltage is going a lot higher now as it's controlling the speed of the motor. Where's my buttons here to make this thing work? Ha ha ha! Got it! Son of a gun! Unbelievable. You see when the capstan engages as it's going to drop down, as it's going to crank the power up for the motor? You don't know how happy I am right now. I just found a defect that originated from the factory on these things. No heat sink, or no insulator on the transistor. How many of these units got scrapped because of this problem? And because the tech that was working on it couldn't find the problem. Unbelievable. You know, first we've got the wrong diagram in the manual. I'm gonna put this one back together. I'm happy now. That was a good find, that one. Now, don't think that this one was not a major challenge. This one was probably one of the more challenging troubles I've had in a while. Because, you know, you go looking for components. You go looking for components that's failed. You don't think that that somebody screwed up at the factory and didn't put an insulator on there. Now, the fact that this thing ran for so long without blowing up, without acting up, is probably because this metal here being anodized, it's got a coating on it which was insulating it for a while, and it just wasn't conducting, it wasn't leaking much. But over the years, the anodization here on it probably failed in behind where that nut was, and they did have paint on there, so maybe they stuck paint on there and they figured that, and that's probably what kept it going, you know, all these years, was they had some of this red, I don't know if there's still some of it here, came off the nut, but there was like that red enamel paint that they put over the nut just to lock it in place. And that's probably the only thing that was letting this thing work all those years, was the insulating factor of the paint, an enamel type paint, like the translucent red enamel paint. And over the years, that enamel broke down, and then the nut started making a connection to this anode, the anodized heatsink, which is grounded. You see where I'm getting here, right? So now the collector has resistance between the collector and ground, and that's what's controlling the motor. How they control the speed of the motor is there's a DC voltage that is placed on the AC coil. As they raise that voltage, the motor becomes less powerful because it's being saturated with the magnetic field, so it slows down. When you lower the voltage, lower the DC voltage, the AC motor is still getting its 90 volts or so from the transformer. So it's got its AC voltage across the coil, and of course the capacitor here is also, don't worry, the power's off. I wouldn't be sticking my finger across the capacitor if it was powered up. It's also got its secondary coil. There's the AC motor, there's two coils, right? You've got, if we look on the schematic here, you've got two coils, your main motor. One is going through the capacitor. That's what gives you your 90-degree phase shift, which gives you your rotating magnetic field, which allows the motor to rotate. To reverse it, we're just reversing the polarity of one of the coils, and that'll reverse the direction of the motor. But the motor's always going to rotate. As long as you've got current flowing through the two coils, the motor's always going to rotate. And what they do is they apply a DC voltage across one of the coils. And as they raise that DC voltage, that even though there's the AC waveform is still there, which is creating the rotating magnetic field to make the motor rotate, but as you increase the DC voltage is creating a magnetic field which acts as a brake to slow it down. The higher the DC voltage, the more the braking effect. So with this transistor leaking through to this heatsink, which is grounded, we're limiting the voltage. And that's why it was only going up to 45 or 46 volts. Not high enough. It needs to be 50, 60 volts in order to brake that motor to slow it down enough. That was a tough one. I'll bore you guys with the reassembly process on this thing because these are, as I say, they're hard to work on. Little circuit board's got a clip up there. And they got all these little brackets that all have to come out to take these things apart. Watch this thing have something else wrong with it too. Better not. I'll be testing it before I put it all together just to make sure everything's working, but I just want to get the chassis back together so that I can run it and listen to it. It's 2-0 now. Vancouver is beating the defending Stanley Cup champions St. Louis, the first round of the playoffs. But this is game number 2. We kicked their ass the other day in game 1. It looks like we're doing the same today. I've got the sound turned down because I'm sure if the sound were to be playing in the background, the NHL would give me an instant strike. They're probably going to give me a strike for that bit of that corner of that picture. Well, maybe not, but I remember when I was working on my plasma set back in the spring. It was before the shutdown, so it would have been like in February, I guess, when my plasma was acting up. And when I was testing it, I had a shot of a hockey game in the background. The video didn't even get live. It was like a 5-second shot of they weren't even playing. They were just standing around the goal. It was like after the whistle blew, when I was showing that the TV was fixed. It was like a 5-second shot, a bunch of guys standing around a goal doing nothing, and they hit me for that and took my video down. So apparently the sports teams don't take kindly to any of their images getting shown on anything other than their authorized channels. Like, it wasn't like I was showing the gameplay, it was just standing around the goal. And they, so you gotta be real careful with any of the professional sports. Don't have any sound or anything on, because they'll use any excuse they can to take your video down, so it seems. So I'm just gonna check the speed again on this thing, since I've now fixed the problem. I'm sure that the speed is all out of whack, so we'll plug the scope, plug the scope into it. I'll do the speed test for the 7.5 and the 3 3/4. I'm gonna use this bad boy. Ignore the little blip 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 that you hear in my tone, because unfortunately, stupid me, the tape was set down near a magnet, and every time the reel makes a rotation, you'll hear a little blip as my tape got kind of messed up, my tone tape. So yeah, we are a little bit hot now. It's not doing it now. If I rewind the tape back a bit, you'll hear it. There we go, 4 kilohertz. Look at that, dead on. I'll do the 2 kilohertz now for this. Good enough. I'm liking it. We ready for some music bakery? Let's let it sit and see if it's going to speed up. Perfect. I like this deck almost as much as I like my own. I have a 260D, and the only difference between the 260D and the 270D is that mine will record in both the forward and the reverse direction, whereas this one only records in one direction. I think this is a 4-head, if I'm not mistaken. It's got a 4th head for playback. Okay, it's got a playback head here for the reverse direction. Look at all the dirt on here. An erase head here, a record head here, and a playback head for the forward direction. So mine has basically two of these assemblies. It's got an erase record. It's actually a combination head, but it's actually two separate heads. But it's replaced as a combination unit. So mine's got my combination, erase and record, followed by a playback head, followed by a central capstan, because mine's got the capstan right in the middle here with the pinch roller below it. So it's got an erase, record, play, or erase, record, and a play, capstan, and then it's play, record, erase, so that when it's going the opposite direction. So this one here is record one direction, play both. That's the big difference on this one between this one and mine. And because this one here on reverse play, your capstan and shaft is pulling the tape, feeding it through. They have this other roller over here, which this is just a weighted passive roller, but that's to take up to reduce the wow and flutter. In reverse play, obviously the quality is probably not going to be quite as good as it would be in the forward play, just because you're pushing the tape through rather than pulling it through. So there's always going to be tape tension variations. They got a tension bar here, but there's still going to be tape tension variations, and their wow and flutter is going to be higher on this deck in playback in the reverse direction than say mine, which has got dedicated playback head, and the capstan is centrally located, so it pulls the tape regardless which way it goes. And mine reverses instantly. This one here, it stops, it goes clunk, the remoter has to reverse, and then it starts up the other way. Then the pinch roller engages again. On mine, the motor just reverses direction. It's still a 3-motor system. Mine's belt drive, mind you. This is direct drive, so there's some advantages to the direct drive. And but other than that, they're very good decks. The downfall of these is the glass heads, which is great on an oxide type tape like this, but if you put on one of those back coated tapes or any of the ones from the sticky shed syndrome era, yeah, they don't like them at all. They stick. The tape sticks to the heads basically because they're so smooth. So to give you an idea of the speed that this one reverses, watch that TV in the background there. Hit reverse play, and it stops. Same as going into play. And you'll see this roller here will start to turn. Of course, if the tape reel were to get stuck in reverse play, you're going to have a big problem, because it is going to continue to spool that tape until it is all over the place. That's a problem with this design. Check this out. I wonder what this is worth. It's 23 karat gold leaf. Real gold. You write onto it, and it transfers onto the you put the strip down, and then you write onto this, and it writes in gold, but it's actually, you write through the wrapper. You peel this over like this and put it onto here, and then you write onto this, and it transfers in gold onto this. Genuine 23 karat gold. I bet you that's worth a couple dollars. Just it's very thin. It's just rolled out actual gold leaf. That was these tapes. These were Ampec 541. This came in the box. I've got a whole box of these tapes that have never been used, and it's a great tape. Doesn't have the sticky shed problem, and they sound great. Like I say, I got a whole box of them that are unused, still factory sealed. I opened up one. Actually, I opened up two. I opened up one brand new one to make this tape, and I have another one that had some stuff recorded on it that was recorded in mono, and it was crap, and I just used it for recording over. The person that gave me this, they actually used the gold leaf to mark the tape. I think this is the one that I've just been recording on. Oh, we got a problem still. That's the record play switch. Better clean that. I better not let that play. I better not let that play. Got some big wreck on that tape. The record play switch is right on the, or not the record play, the tape source switch is right on the side here, so I can get in there with cleaner and clean that switch up. Okay, try it now. I think I can record on this tape just after this is recorded. This was a live recording.
All your excuses for everything.
Okay, let's set this thing up to record. I will record. I got zero my counter here. Record and play. We'll set the next track up here and let it go. Rewind that back and take a listen to it. So switch that back to tape. Why do we only have one channel? Do we have another problem with this, or that switch is still dirty? Yeah, that switch is still buggered up. That was causing the left channel to cut out before. I gotta get some more cleaner in that switch because it's still cutting out. There, that's a little better. Pause. Yeah, what happened is this switch here has got a sealed back on it, and I was trying to spray it in through a little access hole, but I guess the cleaner wasn't getting into that access hole, so I had to actually get in here a little more and get right into the back here. There's a small space. I don't know if you guys can see it on camera or not, but there's a small space where the spring lives for the toggle. I don't know if you guys can see it on camera or not, but there is a small space in there that I was able to get the nozzle in. Get some cleaner in, so hopefully it's clean this time. Anyway, time to put this one back together as it's working. So I'll just take the tape off here, put this one back together, and we'll sign off on this one. How to put this thing back together. These wonderful pieces of crap. Let's get the camera above my head so I don't have to hit it. So to put these things together, we just tip the thing forward, slide the base in, kind of like that, and then it will stand up and go back into the cabinet. Just like that. That's how you put these ones back together. And then there's 5 screws in the back and 2 in the base. So the feet plus that screw, and the other foot's on here somewhere. There it is. And there's 2 more that I have to turn the thing over onto its back to install. The other bolts, 2 of them, 1 on each side, go into the bottom. Okay, that does it for this one. Thanks for watching. We'll catch you in the next one real soon. Be sure to hit that subscribe button, and let's get my subscriptions up over 100,000, and then we'll shoot for 1 million. But we're shooting for 100,000, and I'd like to hit that before the end of the year, which I should be able to do. With your help. Thanks for watching. We'll catch you in the next one real soon. Bye for now.